So this is part 3 of the nonsense I was taught in relativity, and it's quite a bit longer than part 1 and part 2. I was hoping to make short little videos, but there's quite a lot of nonsense being talked about in the part I want to deal with here, and so it takes quite a lot of unpacking, and it's to deal, of course, with the ether. So let's get on with it. So carrying on dealing with Open University booklet that is used to teach relativity. By relativity means special relativity. Where Open University presents 3 possibilities for light motion and is in the process of showing most of those possibilities are wrong, and the aim being discarding those wrong possibilities, leaving relativity as the answer. The first possibility having now been dealt with, and now moving on to the second possibility. But as I'm noting, Open University is only presenting simple alternatives and not presenting complicated alternatives to relativity. And Open University is, in other words, only presenting weak contenders to go up against relativity and not presenting a strong alternative stroke contender. Thus the contest is rigged. So here's the contest, where you have relativity, which is presented as a really strong person, really big giant, full of muscles, and he's going to go fight against somebody who's a lot smaller and a lot weaker than himself. So one big hit from the strong giant, and he's going to knock out the little person. Anyway, I'm going to carry on with the weak contenders that Open University is presenting. And where we got to last time was the empirical evidence that Open University presented was pointed out by this book below as explainable by ether stroke preferred frame. The book says one possibility of avoiding contradiction in the particular example would be given if there existed a preferred coordinate system, or ether, with respect to which an absolute velocity could be defined and which had the property of transmitting light at the fixed speed c. The idea of an ether suggests itself by analogy with the propagation of sound, which requires some underlying medium, air for example, for transmission, in which one observes the speed of sound independent of the velocity of the source. And so there's a possibility of the situation where you have a preferred stroke ether frame, and that would be a more complicated theory explaining what is happening, and Open University in its booklet is not dealing with that. It's instead only dealing with its 3 simplest possibilities, and ignores the more complicated possibility of an ether, and ether gets more complicated because there are different versions of ether. I'm not agreeing with how the book is presenting ether, and unfortunately the book thinks the Michelson-Morley experiment disposes of ether theory, but it doesn't, because there are different versions of ether. If thinking in terms of simple ether theory, then maybe you can dispose of it, but there are more complicated versions of ether theory. So unfortunately, I'm referring to a reference which I'm not agreeing with. I'm agreeing in part with what that reference is saying, but I'm not agreeing completely with what that reference is saying. And so this is how you get the nonsense piled on top of each other. And I'm trying to unpack that nonsense. And so back to Open University, in its booklet, it asks the question that it hopes to answer: is c the speed relative to space ? And Open University says this section deals with the interpretation of c that Maxwell himself would have given, though he would not have posed the question given in the title in terms of space. Maxwell would have used a more technical term, the ether, a term that will now be explained. So the question being asked by Open University, it's really asking about the ether, and Maxwell's electromagnetic theory has an ether. And what Open University hopes to do is to discard the ether and hence modify Maxwell's theory from what it was originally, i.e. Maxwell presenting a theory which he believed had an ether, and Open University is hoping to then modify that theory and have Maxwell's theory as not having an ether. So Open University says the following: apart from electromagnetic radiation, the waves encountered most frequently in physics are those of sound propagating through the air. It is well known that sound is unable to travel through a vacuum, a fact which is explained by saying that in a vacuum there is no substance, no medium to carry the sound wave. Throughout the 19th century, it was felt that electromagnetic influences also needed some kind of medium for their propagation. The realization that light, which is electromagnetic radiation, which certainly travels through a vacuum, is an electromagnetic wave, forced those who believe in an electromagnetic medium to grant it rather strange properties. For example, the medium had to fill space, otherwise the stars would not have been visible. Yet astronomical bodies such as the planets had to move through the electromagnetic medium without friction, or else their orbits would have changed. This peculiar all-pervading medium, which propagated electromagnetic effects but apparently did little else, was called the ether. And so, but my comment on that is, based on that, light has a medium called the ether. It doesn't matter that it has peculiar properties, that's just a problem you've got to accept. Open University continues, asking, is c the speed of light relative to space? Does not really make sense. So it raised a question which does not make sense, and this is the problem with relativity. You end up with things that don't make sense. Space does not supply any natural reference points that can be used when measuring speeds, but it is perfectly sensible to ask, is c the speed relative to the ether? So you've changed the question to talk about the ether instead of space. Just as it would be sensible to inquire about the speed of sound relative to the air through which it moves. So my comment on that is, so in space there's an ether, and that is the medium for light waves. Open University carries on and says, having formulated a sensible question about the speed of light in terms of the ether, you can see that an obvious goal for 19th century physicists was to test the ether interpretation experimentally. In a letter written in 1879, Maxwell shows that he knew of at least two possible bases for such an experiment. His ideas were based on the assumption that the Earth's orbital motion around the Sun ensured that the Earth was moving relative to the ether, and this relative motion should influence the speed of light relative to a detector fixed on the Earth. One idea briefly mentioned by Maxwell involves the amount of time required for a beam of light to travel from a point A to a mirror at a point B and then return to point A. Maxwell realised that, according to the ether interpretation, the time required for the round trip from A to B and back would not only depend on the distance between A and B, but would also be sensitive to two other factors. And Open University points out what those two factors are. First one, the speed of the line AB relative to the ether, and AB is meaning the distance from A to B. And the second point is the orientation of the line AB. And so this is the diagram that Open University gives. Light goes from point A towards the mirror at point B and then bounces back and returns to point A. Open University says, note that we are not saying that light does not consist of particles at all, but merely that it does not consist of a certain kind of particle with certain specific properties. And so my comment on that is, so Open University is still admitting there are particles of light despite finding problems with that when looking at the first example of empirical evidence, and that was in a previous video. It's wave particle duality for light. Open University continues, says Maxwell knew that these latter two factors would only have a very small effect on the round trip time, but he also knew that if that effect could be measured, it would provide valuable information about the ether. It would even be possible to work out the speed of the Earth relative to the ether. Open University then goes on to say, a simple analogy may help you to understand exactly why you should expect the round trip time to be influenced by the two factors given above. Imagine that you are on board a boat steaming across a perfectly calm lake. Also imagine that you are a strong and steady swimmer and that you always swim at a constant speed relative to the water, and the water is playing the part of the medium. So Open University continues and says, this situation is analogous to the one considered by Maxwell. The water of the lake represents the ether, and the motion of the boat relative to the water represents the motion of the point A relative to the ether. Of course, your ability to swim at a constant speed relative to the water is the analogue of the Maxwellian idea that light always travels at speed c relative to the ether. Now suppose that a second boat called capital P is steaming across the lake at the same speed v as your boat and on a parallel course, but at a constant distance of 20 meters from your boat. Two of the many possible arrangements of the two boats are shown in figure 4, which will be shown in a moment. If you decided to swim from your boat to boat P and back, what factors do you think would influence the amount of time required for the round trip? Well, obviously the speed of the boats will be important. This is easily seen if you imagine that P is travelling directly ahead of your boat. The higher the common speed of the boats, the longer it would take you to catch up with P. Indeed, if P were moving more rapidly than you could swim, you would never catch up with it. So the round trip time certainly depends on the speed of the boats. You would also find that the time depended on the direction of P from your boat. For example, if P was directly astern, as in figure 4a, you would not be surprised to find that the round trip time was different from what it would have been if P was off to one side, as in figure 4b. Just as the time required for your swim would depend on both the speed of your boat relative to the water and the direction of P from your boat, so the time required for a light ray to travel from A to B and back depends on both the speed of the line AB relative to the ether and the orientation of the line AB. So these are the diagrams that Open University gives, and you've got case A to the left and case B to the right. So hopefully these diagrams make sense to you. The two boats travel along parallel courses at the same speed, separated by a constant distance of 20 meters. Only two arrangements are shown, but many others are possible. In case A, your boat is 20 meters ahead of boat P, and in the other case the boats are 20 meters apart and travelling as shown. So Open University gives the Michelson-Morley experiment, and this is what's happening. The light is leaving the light source, and you've got a semi-silvered mirror, and that splits the beam, so the beam goes up and down and across. And so this is doing a similar thing to what the boats were doing, but in this case it's doing it with light. So Open University carries on and says the apparatus used by Michelson in his attempt to detect the effects of the ether on the time required for light to make a round trip between 2 points separated by a distance capital L. The motion of the earth moves the entire apparatus relative to the ether. And Open University carries on. The first physicist to devise a sufficiently precise experiment to test the implications of the ether hypothesis was Michelson, and figure 5 provides a simplified plan of Michelson's apparatus. A narrow monochromic beam of light was shone onto a semi-silvered mirror at point A, and the mirror split the original beam into two parts that travelled at right angles to each other. The half of the original beam that passed through the semi-silvered mirror was reflected by a mirror at point B at a distance capital L from point A. The other half of the original beam, the half that had been reflected at A, was reflected again by a mirror at point C, which was also a distance capital L from A. After being reflected at either B or C, the two parts of the original beam returned to point A, where they recombined. The recombined beam was then observed from point D. And now it refers to earlier booklets, and from those booklets it says you should realise that when the two parts of the original beam recombine at point A, they will interfere with light. With light or electromagnetic waves, you can get interference patterns. If the time taking for light to travel from A to B and back differs from the time required to go via C by a whole number multiple of the period of oscillation of the light wave, then the interference will be constructive. And that means constructive means that the light, it will be brighter, stronger. The two waves will reinforce one another, and the point A will be brightly illuminated when viewed through the telescope. On the other hand, if the time difference is an odd number of half periods, destructive interference occurs and the point A will not be illuminated. Destructive interference is where the light will cancel itself out. So the existence of a time difference should influence the illumination of point A. Furthermore, rotating the Hall apparatus in the plane of the points A, B and C should change the orientation of both the line AB and the line AC relative to the direction of the Earth's motion through the ether. Such a rotation would therefore alter the time delay along each path and thus change the illumination of point A. It was this change in illumination as a result of rotation that Michelson actually tried to detect. Open University carries on. Michelson first performed his experiment in 1881 and found no sign of the predicted time difference. His results were challenged, so he repeated the experiment and in an improved form in 1887 with the help of Morley. Once again, there was no evidence of a time difference. The result of this Michelson-Morley experiment has been described as the most famous null result in the history of physics. As far as Michelson himself was concerned, its implication was clear, as he wrote at the time. And so he says, the result of the hypothesis of a stationary ether is thus shown to be incorrect. And so my note on that is, he says stationary ether, and that's suggestive that there is other types of ether, of course. There's more than one type of ether theory. So let's get another point I needed to make, which I didn't write, is it wasn't actually a null result. There was a small amount of effect detected, but it was dismissed as experimental error. So it was deemed a null result based on that. Open University carries on. Despite the failure of the Michelson-Morley experiment to find any evidence of the existence of the ether, and my comment on that is it says ether instead of stationary ether. So it's now making it suggestive that talking about no evidence of all types of ether. And so that's how it's trying to mislead people. It's sort of like stating one thing about a stationary ether. Okay, you haven't detected a stationary ether, but then it's trying to make out that that disposes of all ethers by its simple little trick of wordplay. Say stationary ether one moment and then move on, drop the word stationary and move on to saying ether. And this is how they mess things up. You'd expect scientists, i.e. physicists in this case, to be precise in what they're saying, but they don't. They do their little word tricks. Whether they do those word tricks consciously or unconsciously, they still do them. But anyway, as the sentence continues for Open University, it admits it's not the case for all types of ether. Open University says the ether interpretation of the speed of light was not entirely discredited. And my comment on that means which means wasn't able to completely dispose of the ether theory. It might have disposed of a simple ether, but a more complicated ether is still possible. It's the subtle use of words that can be used to deceive. If a student thinks there is no ether when they have been deceived by the educator's use of words, and by the educators not explicitly and strongly stating that ether is still possible. Open University continues. One possible explanation of the null result, an explanation that Michelson himself accepted for some time, was that the Earth carries part of the ether around with it, just as it carries the atmosphere. And so my comment on that is, note the use of the word possible. We are only dealing with one more possible ether, whereas earlier used the stationary ether possibility. There are more possible ethers that Open University is not going to mention. The above type of ether Open University is going to say is wrong as we carry on. So it's doing, once again, picking on a weak contender to go up against special relativity and saying that weak contender is weak and wrong. So the Open University continues. If this were correct, it would mean that Michelson's apparatus was at rest relative to the ether, in which case no time difference was to be expected. If the two boats considered earlier were both at rest relative to the water, the round trip time for the swim to boat P and back would be independent of the direction of P. Unfortunately for those who believed in the ether, this more complicated mobile ether theory also failed to find any experimental support. As more and more results accumulated, tenable models of the ether were forced to become increasingly complicated. The growth of complexity led to mounting dissatisfaction with existing theories and a willingness to consider quite radical alternatives. And so Open University is admitting that the ether can become a more complicated theory. And so when it talks of radical alternatives, I think there isn't. And Einstein's theory of 1905 is really just an ether theory. Thinking it's not an ether theory is a mistake. Einstein's 1905 theory, calling ether superfluous, is not discarding ether, it's still there. But more on that anon. So what we got here is the mobile ether theory, as opposed to earlier you had the stationary ether theory, and it's admitting that the ether can become a more complicated theory. And I don't think that is really sufficiently emphasized by the people who believe in Einstein's relativity. That those who believe that Einstein's relativity has got rid of the ether, what they really mean is they don't want to consider more complicated ether theories than the dumbed down ones they have been presented with in their education. Open University continues. It was into this atmosphere that Einstein introduced his special theory of relativity. Einstein's first publication on the subject was in his 1905 paper on the electrodynamics of moving bodies. It presented a new way of interpreting electromagnetism that retained the successes of Maxwell's theory but did away with the superfluous speculations about the ether that Maxwell had employed. Thus the ether theory was finally laid to rest by a combination of experimental discovery and theoretical innovation. And it's once again it's making the mistake of equating superfluous with discarding. So there's no laying to rest of the ether, and Maxwell had an ether in his theory, and if you're throwing that out, then you are modifying Maxwell's theory. And the way it's presenting its wording here, thus the ether theory was finally laid to rest. Well, that's false, because as it's earlier emitting, you can form a more complicated ether theory than the ether theories that it is presenting to you. What Open University does, like other educators, is not willing to address properly is the controversy of the ether, and it instead just wants to gloss over it. Doesn't want the students woken up from their slumber to query it too much. The students are presented with dumbed down ether theories, and they're not gone into the issue of more complicated ether theories. So this is what we got, the fight once more, that is rigged. So where we are here now with the Open University booklet, Open University only wants to put up weak contenders for an ether theory to fight relativity. And by relativity I mean Einstein's special relativity. And really relativity is being misrepresented as not having a type of ether when it really needs an ether, i.e. the fight is rigged. So let's now move on to a better account than the dumbed down, distorted account given by Open University. So going into the history of physics relativity in more detail than Open University's distortion, we get from this historian is Professor Norton, who writes about the origins of relativity. Norton says, we now take Einstein's special theory of relativity for granted. The evidence in its favour is quite massive, so that there is little license for skepticism. Our real task is to learn the theory, and there are many textbooks that develop it in an easy to understand fashion. And my comment on that is, I would say the theory has been misunderstood, misinterpreted, and is full of mistakes. And I pointed out what mistake that Open University was making earlier is trying to discard all ether theories by only presenting dumbed down versions of the ether, when there are more complicated versions of the ether, which he's not going to talk about. Now back to my comment on this, on Norton. I could go through everything that Norton says and make my points, but not doing that, instead dealing with relevant bits connected to what Open University says. First I have to deal with a lot of the background before Einstein. So Norton carries on and he says, in 1905, however, when Einstein first introduced it, and by it he means special relativity, it was a strange and even shocking theory. And by the way, it was named special relativity after 1905. Then Einstein did not have the luxury of a simple textbook on special relativity from which he could learn the theory. Somehow he had to see that such a theory was needed, and then he had to devise the theory and know it was not crazy speculation. How did he do that? Do it? Question mark. That is the present topic, the history of Einstein's discovery of special relativity. We shall see that Einstein had no crystal ball. He worked with resources and methods available to everyone. That is the fascination of the episode. We shall see how he took the same pieces everyone had and assembled a masterpiece where everyone else faltered, i.e. failed. So Einstein was supposed to be successful in forming the theory where other people had not been able to form it. Professor Norton carries on, before we look at Einstein's deliberations, we need to see what came before. That came before Einstein. That provided Einstein with the foundation upon which he could build the special theory of relativity. So he points it out is this, Maxwell's theory of electromagnetism, and it comes from volume 1 and volume 2 of this book by Maxwell. Has he got the date? No. So Norton carries on and says, to foreshadow what is to come, we will find that there was no good experimental foundation for special relativity prior to Einstein's time. That is, we needed reliable results on things that move very fast, close to the speed of light, before relativity theory could have solid experimental foundation. That foundation came with the electromagnetic theory of Maxwell and others in the 19th century. It gave the first reliable account of how some very rapidly moving things behave, including most notably light itself. Before Einstein's time, relativity theory could not properly emerge. And by relativity theory, of course, I'm still referring to what's special relativity. Right, so Norton carries on to say, once electromagnetic theory had been developed, there was a sense that relativity theory already lived within the theory, and by that he means there's a sense that special relativity theory exists already within electromagnetic theory. Of course, that sort of thing can be argued with. Anyway, he carries on. Lorentz already discovered that the basic equations Einstein would use later within special relativity. It had become inevitable that relativity theory or something like it would emerge. It was really only a question of who would have the ingenuity and flexibility of mind to find the theory first. That person proved to be Einstein. So what I note from that is before Einstein there was Lorentz's theory, because Lorentz already had the same sort of math that Einstein was going to go and use. Norton continues, the principle of relativity tells us that we cannot detect our uniform motion, whether uniform motion was detectable or not, became a pressing issue in 16th and 17th century. And by uniform motion, it means the principle does not apply to non-uniform motion. Now Norton wants to talk about 16th and 17th century, but I'm going to skip over that because I want to get back to the more relevant bit, which is Newton. So according to Norton on Newton, he says Galileo's work pointed to what the new physics would be like. The work of developing that new physics was completed by Newton in his book Mathematical Principles of Natural Philosophy, 1687. Conformity with the principle of relativity was built into Newton's physics from the outset. So you had Newton, Galileo, relativity within Newtonian physics. So Norton carries on to say, to see how, consider a naive physics that arises from casual observation of ordinary things in the world. The default natural state of bodies is to be at rest. People, animals and objects do not move unless something makes them move. Those motive powers set things into motion and must maintain that action on the object if it is to keep moving. A cart is moved by a horse and stops moving when the horse tires and stops pulling. Newton's Principia change this default conception at the outset. The natural state of bodies, according to his first law of motion, is uniform motion in a straight line. If left to themselves, bodies would, to use the later expression, persist in inertial motion. Deviations from inertial motion are due to impressed forces. According to Newton's second law of motion, these forces do not cause motion, but changes of motion. In a more recent formulation, we associate forces with accelerations. These two principles made it possible for Newton's physics to conform with the principle of relativity in the most important aspect. Processes we can measure and check run in the same way in all uniformly moving systems. Nothing in them will allow us to pick out the motion of one as preferred. We may be on a rapidly moving Earth, but casual observations and experiments will not reveal it. Norton continues. Newton did not write explicitly of the principle of relativity. This focus on it as a principle is a late 19th century and early 20th century innovation. Rather, he built his physics, as we saw in an earlier chapter, on the notion of absolute rest. The principle relativity was respected in the weaker sense that no experiment we could do on the Earth would reveal a motion with respect to this absolute state of motion. Now, there's a lot said in my comment on that. There's a lot said of interest, but getting on to the next relevant bit, Norton says, what altered this happier arrangement in the 19th century were advances in the theory of light. Newton has supposed that light consisted of rapidly moving corpuscles. They obey the principle of relativity as much as anything else in his universe. Following the work of Fresnel and others early in the 19th century, this account was replaced by one of light as a propagating wave. And my comment on that is now you have wave-particle duality. And so passing over that issue of particle theory light versus wave theory light, except for noting that light as a wave needs a medium, which we call the ether. So my comment is saying that experiments were made in an attempt to measure relative to ether frame. Moving on to the most relevant experiment about that is the Michelson and Morley experiment, which Norton explains. After first order experiments came second order experiments. These sought to measure the very much smaller second order effects. They needed instruments that were a great deal more sensitive to ether currents, for they had to be able to detect the residual second order effects that might remain after the Fresnel drag had protected first order effects from detection. This added sensitivity meant that second order experiments were a great deal harder to carry out. There was only one successfully executed in the 19th century, the celebrated experiment of Michelson and Morley of 1887 that completed Michelson's earlier efforts at such an experiment, and he notes that Michelson won the Nobel Prize. Norton goes on to say the basic idea of the experiment is that light moves differently on a moving Earth according to whether it propagates transverse to the direction of the Earth's motion or parallel to the direction of the Earth's motion. In the first case, the ether current flows across the propagating light, slowing it a little. In the second case, it provides a kind of headwind that slows the light more, or a tailwind that speeds it up. And so this is the diagram that Norton gives. So after explaining the experiment, Norton then reports on the result. Norton says the result was negative. Michelson and Morley found shifts in the interference fringes, but they were very much smaller than the size of the effect expected from the known orbital motion of the Earth. And so that was taken to mean no motion detected relative to the ether stroke preferred stroke absolute frame. So after pointing out that this is a mystery, Norton goes on to say, how is it possible for Maxwell's electrodynamics to be based fundamentally upon the notion of an ether, yet no experiment can reveal the magnitude and direction of the ether current? Question mark. This was a problem taken up and solved brilliantly by Lorentz. Norton goes on to say, Lorentz first simplified Maxwell's theory into the form that is routinely taught today. All matter, he proposed, simply consists of electric charges, and that these are called ions or electrons, in the empty space of the ether. He then proceeded to show how electrodynamical theory could explain the failure of the experiments to produce a result. So what Norton is noting is that Maxwell's theory is getting modified. Same as Open University notes that Maxwell theory gets modified. And Norton is saying it's being modified by Lorentz, and Open University omitted to say that. So Maxwell's theory becomes Maxwell-Lorentz theory under this modification. So after a lot more explanations about experiments, Norton goes on to say, the 20th century opened with the Maxwell-Lorentz theory of electrodynamics as the most successful physical theory of the era. While that theory was based essentially on the existence of an ether, the failure to detect ether currents was no longer a puzzle but a prediction of the theory. Lorentz showed that the theory entailed effects whose combined import was to make the ether current invisible and the absolute motion of the Earth undetectable by us. We might be moving through the ether at some definite speed and in some definite direction, but the physics of electrodynamics conspire to prevent us ever measuring that speed and direction. So Norton is now saying that the Maxwell-Lorentz theory and its prediction is that the ether exists but can't be detected. And that should ideally be the theory of electromagnetism that Einstein was working from in 1905. But contrast that with what Open University says. Open University is not sufficiently admitting that the ether exists, and is written in such a way can deceive students it's teaching that the ether doesn't exist. And so Open University does not want to address the controversy that the ether exists and hides this by saying to keep the simple versions of the ether and not to go to the more complicated versions. Going by Einstein 1905 special relativity paper, he talks to the ether as superfluous. But superfluous does not really mean non-existent. He must be talking of his treatment in that paper as him not using it, but he brings it back in a talk in 1920 and that's in a paper called Ether and the Theory of Relativity, and you can see that link. He talks of there being some type of ether. So when the mainstream have their rigged fight, the strong contender is not even defending what Einstein's position really is. You have the strong contender being misrepresented as having no ether, and it goes up against dumbed down versions of ether theory. Is not prepared to put up a strong ether theory contender to go against Einstein, and that's how it deceives you. And I had to bring it in Professor Norton's account of the history of special relativity to show what the Open University book was omitting in its distorted version of history and its distorted representation of special relativity. The Open University book doesn't want to address the controversy over the ether as existing, even though it can't be detected. And the issue of it can't be detected, I would argue against that as well. But that's the position that many historians have, such as Norton, that you have the Lorentz theory with an undetectable ether. So when the controversy is, if you had Einstein's theory versus Lorentz's theory, are they the same theory or are they different theories? And it doesn't want to tell you that, the Open University. They just want to cover that up. So thank you, that's the end.